Hi, we're going to look at another related rates problem. So we've got the word problem description up here. I'm not going to read that to you, but just point out some important features here. So we've got an equation given. So this is a real equation with some ugly coefficients. Often equations based on data are like that. So it's used to estimate the surface area when we know weight and height. Okay, and we've got some information in this problem that tells us that some of these things are changing. So that's how we know we've got a related rates problem. All right, so we're going to set up, just like we did with the other related rates problems, just a list here of our variables and rates, and identify what is happening in the problem, rate of change. Okay, so if we read the problem here, we see that we've got surface area. So that's one of our variables, and so ds dt would be a rate of change for that. We've got weight and a rate of change for that. And then we've got some information here about height. Okay, so these are the variables that are mentioned kind of in the first sentence. And then if we read the other information that gives the numerical values here, it says that the woman is 160 centimeters tall, so that's our height. And weighs 55 kilograms. Losing weight at a rate of 0.25 kilograms per week. So since she's losing weight, we've got a decrease in W, so this is a negative rate of change, 0.25 kilograms per week. And we're supposed to find the rate at which the body surface area is changing. So this is what we want to find. All right, the other important thing about this problem, besides the fact that we have this kind of ugly formula with some ugly numbers here, is that in the description of the problem, it tells us something about height, but it doesn't ask us or tell us anything about whether that height is changing. And so if somebody's losing weight, generally, their height would not be changing. So in this problem, if you read this carefully, you might notice that h is not really a variable here. H is really a constant. So really, I only have two things that are changing in this problem, body surface area and weight, and h is a constant. So I don't really need to worry about that as a rate of change. The other thing that means is that in this problem, if I have something that's staying constant that doesn't change, I can substitute that number into the problem at the very beginning before I start taking derivatives, and that maybe makes things a little bit cleaner. All right, so I'm going to go ahead and do that here. So I'm going to rewrite this formula with our h put in place. You might notice when I do that, I only have one variable left on the right side of the equation. So I'm going to put all the constants kind of out front. So I'm going to rewrite this equation here with our h put in. So we'll have s equals, make sure I get this decimal number written correctly, 7184. I'm going to put the 160, erase that, to the 0.725 in front, and then my W to the 0.425 here. So you want to be careful when you do that, that you only do that if your letter is constant and not changing in the problem. So a common mistake is that sometimes students will put in numbers for everything before they take the derivative, but you can't do that for things that are changing. All right, and now I want to differentiate both sides of this equation with respect to t. So that's what we've been doing all along in our related rates problems. So differentiate both sides of the equation with respect to t. On the left side then, we're going to have ds dt. And the right side, it looks like kind of a mess here. But really, if you think about this, this is all just constant out front. And then I have a power, my variable to a power. So that's the easy derivative that most students know pretty well. Bring down the exponent and subtract 1. All right, so I'm going to have this constant out front, 0.007184. I'm going to use parentheses to kind of help me keep my pieces of this constant straight, so I'm clear about what is raised to each exponent here. So, all right, so there's the constant that's out front, and then I'm going to bring down this exponent, 0.425 times w to the, and then my exponent here, I have to take this exponent minus 1. So 0.425 minus 1, I'm going to have negative 0.575. All right, one other thing here. Remember that we're differentiating with respect to t. So when I differentiate this with respect to t on all these related rates problems, you have this extra dw dt every time you take the derivative of a variable with respect to t. That's really chain rule going on right there. So that's a really common mistake, is that students forget to do that. But remember, we're doing a related rates problem. We've got all these rates that change. If you didn't notice that at that point, then at the next step, when you're ready to plug in some numbers, maybe you would notice that you forgot a dw dt that should be in there somewhere. OK, so once I've differentiated, then I'm just plugging in the numbers and finding what I need to find. We were not given s, and so then maybe we need it and maybe we don't. If we did need it, we could use the original formula to find that. But looks like I don't need that here. So I'll just go ahead and plug in all of the numbers and find what I need to find. All right, so my ds dt equals, and then here, 0.007184. My w is 55. I'm going to use some extra parentheses here. So 55 to the negative 0.575. And this one is so long, I'm almost out of space here. But then we need to take that times my dw dt. So times, I don't know if it'll quite fit there, negative 0.25 times all that. OK, so at this point, I have all those ugly numbers, and that would be in exact form my answer. I could tidy some things up if I want. I need to pay attention to units. So s is given in square meters. It tells us up in the problem. And t is measured in time. So this would be in square meters per week. So if you talk about somebody's surface area changing in this number of square meters per week, maybe this is one where you want a decimal approximation. So you get out your calculator. You type all this in very carefully. I typed it in twice when I typed this in, just to make sure I got all my zeros and decimals and negatives in the right place. So when I did that, I got an approximate value. So I'm going to show approximately equal to negative 0.0030, rounded to 4 decimal places there, square meters per week. OK, so the part at the end here wasn't too difficult. It's just plugging in numbers and using your calculator. The main point of a problem like this is kind of dealing with an ugly formula. The derivative actually was pretty easy. We just had some ugly coefficients in it. And then the other important part of this problem was this idea here, where I have one of the variables given in the equation, but it's not really changing. It's staying constant. So I was able to plug that in at the very beginning. All right, we'll look at one more example that uses this same formula, but has everything changing. So the derivatives will be a little bit more complicated. So we'll look at that in the next video.